we should show them in books. But we never do, don't we? We don't see that picture, but that's what it should be. So, for yourselves, if you like this activity, it's dead simple. Whatever size ball you get, you don't have to have a blow-up globe. Get a football, get a basketball, whatever. Wrap string 10 times round, and that's how far it's away, roughly. Those figures not bad. So dead easy to remember. Get a ball, wrap it 10 times round, that's how far the Earth would be away. Dead simple activity. Thank you. You're a wonderful Earth, a wonderful Moon. Thank you. Thank you. So, borrow that. Excuse me. So, another activity. What about the other planets? We see these models. That's just a child's toy that sort of sits in a pram, and then that is a model. We've got one in the Space Centre. It's a model of the solar system. But again, it teaches people wrong. So what I've done for you, there's not quite one each, but sort of one between two. There's about 5 or 6 on each table of these. So, here is our solar system, right? This is the task. I've got some pens as well. That is a small section of the sun. So that's the sun. Here, I've marked where Neptune is. I've not put Pluto, obviously, because Pluto's not a planet anymore. So I've put Neptune. So, here's the task. Could you know, based on just pure guess, again, this is a typical teaching activity. I've just given it to my students as what I would call a starter exercise. So I have not taught them anything. It is literally complete guess. I give this to them and I say, on this line, don't draw them, just mark on that length line, perhaps with an arrow, like I've just done. Where do you think the planets will be? Right? And they look at me saying, Andy, that's an interesting point you're going to meet about my students calling me by my first name. My students will call me Andy. You'll be interested when you go around other schools and you see whether people call Sir, Miss, Mr, whatever. I don't. It's just a side point. They call me Andy. So they'll say, Andy, I don't know. And I'll say, it's okay. Just have a guess. Where do you think? And then I'll tell you the answer. So just spend 2, 3, 4 minutes. I've got some pens here. If you need to come and grab a pen or mark, just have a go. Try and mark on where you think the planets would be. There's sort of one between 2-ish.
حصل اجتماع سنة 2005 علماء الفلك حطوا شروط قبل الاجتماع ده قعدوا سنين فاتت كل 2-3 واحد يكتشف بتلسكوب كوكب ويسميه باسمه مثلا يوم مش عارف 2013 فقالوا احنا لازم نحط شروط لحاجه للكوكب فعملوا شروط بعد ما عملوا الشروط لقوا الشروط دي ما بتنطبقش على مين ما بقاش بس هو موجود في مكانه عشان في متخلفين عندنا في مصر في متخلفين عندنا في مصر بيقولوا اصل ساب مكانه ومشي هم قالوا ده هنا كان الشرط هم اللي حددوا لا مش تبع
على فكرة احنا كده هنبين هو بدل جد
بص يعني
4 minutes. It's a real big thing in schools in my teaching. What I teach my teachers, when a teacher says 4 minutes, they mean 4 minutes. So it is strictly 4 minutes. Okay? 4 minutes. We've only got 4 minutes. We need bins.
you want to pay? Let me find
Only one place.
Yeah, you'll see whether it's right in a moment. You'll see. Brilliant.
انا مش عايز
That one. Fantastic.
الناس اللي ده يا اسطى ده نيوتن يا اسطى دي الشمس عايزين كده بالصلاه على النبي عايزين كده بالصلاه على النبي نحط الباقيين هنا
انت هتحطهم كلهم
متري
كده صحيح. انا عايزه افهم انت بتعمل ايه بدل السكه مش كل كده يا مستر
لا بس هم في القريبين فعلا بيبقوا قريبين المعاد بيبقوا معاد
لا نبتون واورانوس قريبين قوي
انا مش فاكر بصراحه انا بركز فيها اساسا انت بتصورها يا مس؟ بتصورها يا مستر احمد
has either collided or shattered into lots of little bits. And we think then the gravitational field
وبعدين في منطقة
طب هو دلوقتي الجو بينتهي عند 100 كيلو امبارح عندنا في الكتاب هي 1000 جنيه لا انا مش متناقض هو بيعتبر ان بعد كده من اول الاختراق ما بيعتبرهاش هي تراث
Okay. You'll have a go. We'll see. It's not. But go. 2 more minutes. 2 more minutes. Quite a few people had to go.
Is there a corrector?
And I'm going to tell you. I'm going to tell you a dead quick answer.
Can I use it?
He's got a question.
I want to ask about something. We use that and you said that the starting of space from 100 kilometers. What about the specimen which found greater than 100 kilometers?
Sorry, go on. Yeah. Yeah, it goes up to much higher than 100 kilometres. Yes. 100 kilometres. Yeah. Do you want me to explain why?
Why?
I will do that to the rest of the group. Will the rest of the group be interested, do you think? Yes. There is, because we're physicists, there is an aeronautical reason. Yes. Good question. I didn't actually explain, I just said it was 100 kilometres, yes. Okay, that's time up. I've had a fantastic question, and it's my fault. We are science teachers, and we do want to know, and you're absolutely right, why 100 kilometres? We said space started at 100 kilometres. Why 100 kilometres? And it's because clearly the atmosphere does go much higher than 100 kilometres. And it's not because it's just an easy number. There is a reason. Okay. To produce lift from aeronautical flight, from a plane, you know about the shape of the wings. If you produce forward velocity, you have a different airspeed over the top to the bottom, and that produces a difference in pressure, produces lift. I would call it the Bernoulli effect. Again, I'm not sure whether you'd use the same words in each. I presume it's called the same thing, Bernoulli effect. As you go higher, the atmosphere gets thinner. To produce the same amount of lift, you have to either have bigger wings or you have to travel faster. There is a point where, and that's this line, where you could, if you travelled fast enough to produce lift, you would be at the escape velocity of the Earth. Yeah. So you would then enter free fall.
Free fall. Yeah.
You'd enter orbit. Okay. So you can't fly. You can't actually have aeronautical flights at that height because you'd be travelling so fast you'd actually enter free fall. You'd actually enter orbit around the Earth. So that's the reason why It's the balance between aeronautical lift and forward velocity.
Okay.
It is named escaping velocity.
It's escape, you'll be travelling at the escape velocity, 8 point something kilometres per second. Yes, it's called the escape velocity. Yeah. So this is the idea. And the reason why I said it to you, I'm not testing you, but I wanted to show you that in sort of one big thing of teaching in English schools is I teach my students it's okay to get things wrong. It's fine to make an educated guess.
Yeah.
So I could do this. I could give you the numbers and you can start putting a scale on it. But it's dead simple. Roughly how it works is this. Fold it in half. Where that crease is will be the first planet. So the first planet, Neptune's there, Uranus would be there. Fold it in half towards the Sun, fold it in half again, and the crease where I'm folding it half again would be Saturn. Fold it in half again, and if you keep folding it in half, roughly, people are going to argue, going to look at the physics and look at the numbers and say, well, it's not quite, but it's not bad. Fold it in half again, and then you start getting quite difficult. But if you keep folding it in half, on each fold towards the Sun, they would be each planet, roughly. So that's a really neat, if you've got students, perhaps younger students, who look at those numbers and think, well, my students, younger students couldn't cope with millions and you perhaps write them a standard form, perhaps would struggle with that. Well, just get them to fold it in half and roughly that's not a bad solar system. It's about right. It's quite a neat little, just dead simple, dead quick. Anyone can get this size paper. Just dead simple sort of activity. So then I do this. So we've got an idea, all right? So let's build one. Let's build a solar system. So I give my students a football. Normal football. This is one activity we're not going to do because it takes too much time. But then I give them a big box of other stuff. I might give them all different size balls. Okay? And I say to them, you pick what you think are the size of the planets. So I go back to that table, they've got some idea of the diameter, and they have to build a solar system. And this works really neat. If I give the Sun a football, then the Mercury will be the size of a pinhead. Yeah. So I'll get some. If you haven't got a pinhead, get the smallest ball you could find, and so on. A peppercorn, pinhead, and now a conker. Now that was a hard one. I don't think in Egypt it's called a conker. It's a horse chestnut fruit. You'll see the sizes. A cherry tomato, a raisin. And so I get them to pick these objects. Again, you can have this. So you don't need to jot them down. You can have this, and we can try and chat about what the sizes that is. So I've got them to pick. And so I've got my students. So one student's got a football, one student's got a pinhead, one student's got a peppercorn. And then I say to them, on this scale, will you stand where you think they should be? And as a class, we go out onto the field and we'll stand where we think it should be. And this gets really great. Mercury has to stand 6 metres away. Right? So I've got one student, so picture it. All right? And it's a great activity. Picture it. You've got a student with a football. What you always pick is your naughtiest lad. All right? The lad is always fidgeting and won't sit and listen. You give him the football because he's sitting there going, I'm the sun, I'm the sun. And then you've got somebody holding a pinhead. They're Mercury, 6 metres away. And now the students are getting a real feel for it. And then we get Venus. Who wants to be Venus? Right, Venus, you can stand there. And they get standing there. And so on. Now 15 metres, 23 metres. We can't do it in our classroom. Okay, let's go on to the corridor. And then it's brilliant. The principal or head teacher, I don't know the leader of the school, principal or head